So, solid state. What are the characteristics of the solids? So, characteristics of a solid. Characteristics of a solid. It has a fixed fixed shape. See how many. See, matter consists of. If you take the matter, that means it exists in three forms. That is solid, next is liquid, and next is gas. So here solid, we are dealing with the solid. So solid state, in this solid state, characteristics of the solid is it has a fixed shape and fixed volume, and fixed volume, shape and volume, and fixed incompressibility. Next thing is it has a rigidity. Next, very low rate of flow. Unlike gases, it flows low rate of flow, diffusion or flow. Solid cannot diffuse, and very low entropy, very low entropy. So here if you see this entropy change will be positive for gases and negative for solids. Negative for solid. So here this is about very low entropy. Solids are broadly classified into two types. How many types of solids are there? Solids are broadly classified into two types. How many types of solids are there? There are two types of solids are there. One is crystalline solid and amorphous solid. So another thing is amorphous solid, crystalline solid and amorphous solid. In this solid, if you see the crystalline solid, in this solid, particles what are particles are what we have atoms aim. So atoms or ions or molecules are arranged in a regular three-dimensional fashion. That means how many dimensions we have. If you take this is x-axis, this is y-axis, and this is z-axis. So these are arranged in a three-dimensional fashions. And in this solid, in this amorphous solids, particles are arranged randomly. They are arranged, and this is a three-dimensional fashion. So it has a regular order. That means it has a sharp melting point. Is present in this crystalline solid. Sharp melting point is present. In this amorphous solids, there is no sharp melting point is absent. Next, heat of fusion fusion heat of fusion is fixed. Heat of fusion is fixed in this case. That means is the temperature at which the solid becomes a liquid is heat of fusion. So the amount of heat required to change its phase into solid from liquid, that is called the heat of fusion, is fixed for this crystalline solids. And heat of fusion is not fixed. Heat of fusion is not fixed for amorphous solids. And important point is these solids are anisotropic. These solids are anisotropic. These solids are anisotropic. What is the meaning of anisotropy? Is the magnitude the magnitude magnitude of physical properties are different in different direction, but there is an exception for the cubic crystalline solid. This is cubic crystalline solid exception because it is a all edge lengths and alpha, beta, gamma values are same. So except cubic system, all solids are in anisotropic in nature. Means they show different magnetic electric properties in different directions. In different directions they show different physical properties. Next thing is here the solids are isotropic. These solids are isotropic. That means the magnitude of physical properties, the magnitude of physical properties are same in all directions. So this is about